All right, well, welcome and thank you for coming. I'm CJ Woolard. I'm a senior principal engineer at Uptake.
Ouch.
Yep. And I'm here with my colleagues, Dan Collins and Brad Bovin. And we're here today to talk about data engineering the startup way. So in terms of a quick agenda here of what we'll be covering, I'm going to talk through a brief introduction of Uptake, who we are and what we do. I'm then going to jump into some of the fun and interesting challenges that we run into on a day-to-day basis. And then going to turn it over to Dan here, who's going to talk through some of the interesting facts of life that we deal with as a result of those challenges. We're going to talk through how we've evolved both our platform and our company over the previous few years to deal with some of these facts of life. And then finally, we're going to close with some lessons we've learned along the way, hopefully some of which will help you along your journey as well. So if there are three things we want you to take away from this talk, the first is, if you're not familiar with Uptake, we want you to hopefully walk away a little bit more familiar with what we do and the problems that we solve. Hopefully you'll learn a few things in terms of how AWS can make your lives easier and how it's made our lives easier. And then finally, as I mentioned, hopefully some of these lessons can translate to your journey as you evolve your startup. So if you're not familiar with Uptake, Uptake is the leading AI software provider for industrial companies. We were founded a little over 4 years ago by our CEO and co-founder, Brad Keywell. Our president is Ganesh Bell.
It crashed. It just crashed.
Okay. As I mentioned, we have over 100 customers right now across several verticals, and I'll go into a couple of those verticals here in a moment. And we've also been honored along the way to receive a number of awards. We've been named twice to the CNBC Disruptor 50 list. We've been named to the Forbes Cloud 100 list. We were named by the World Economic Forum as a technology pioneer. And then best of all for us, we're also named one of the best places to work for in Chicago, which is great. So in terms of Uptake at a glance, as I mentioned, if I jump into the verticals first here, one of those verticals is rail, where we currently provide about $480 million in potential value a year monitoring locomotives in the field. So when a locomotive breaks down, it's not only expensive to fix that asset itself, but also in terms of the downtime and disruption to that rail line. The wind vertical there up at the top, we generate about $3.3 million in potential value a year per wind park. And we do that predicting things like main bearing failures on wind turbines. In terms of some interesting numbers up at the top there, we've already accrued over 1.2 billion hours of machine learning data. We've done that by monitoring over 200,000 assets in the field. On the data science side, our data scientists are inventors on over 150 patent applications. We have over 1,300 deployed models in production, and it takes us a little under 2 minutes to deploy a new model into production, which is pretty cool. So before I jump into some of these hard problems that I mentioned, I want to give a little bit of context so it makes more sense to you. At a high level, what we do is something called Asset Performance Management, or APM for short. And essentially what that means is we monitor all sorts of assets to make sure not only that they continue to operate, but operate efficiently. And in order to do that, we lean heavily on our data scientists to build out things like predictive analytics, anomaly detection, label correction, and then finally we've built a set of applications and AI UX over the top of that to be able to surface the insights that are generated back to our end users, which is ultimately what they care about from our platform. So in order to power those data science models, we need two categories of data. The first is telematics data. So this is high volume, high velocity IoT data, which is ingested either directly off of sensors on assets themselves or via a set of intermediary systems. And then the second category is something we call contextual data. This is additional important or useful information about the assets we're monitoring themselves. Things like work order history might be important, and they better inform the data science models that we run. And we collect that information from a set of resource planning, customer relationship, and content management systems. So at a very high level, what we want is information about assets in and generated insights out, which sounds pretty easy, which brings me to those hard problems. So the first challenge we ran into is that all data, but especially industrial data, is very dirty. So it often arrives out of order. It's highly volatile. We often receive system-wide snapshots with no deltas. It comes to us in many predetermined aggregations, which oftentimes don't line up with either the algorithms or the grains that our data science models require. And then just in general, it often comes in duplicated, partitioned, encoded in all sorts of crazy formats, compressed. And to make matters worse, industrial data also has a past. So a lot of the systems that we integrate with are very old systems. They were designed for other purposes. As part of that, they're susceptible to a set of policy changes. So we run into things very often where a customer may have changed the meaning of a timestamp from local to UTC time without recording that anywhere. They may have a certain field that they rely on, and the context of that field's changed 5 or 6 times over the past 20 years, but they want to maintain that context for each of those changes. And then finally, most of these integrations do have standards usually that they follow, but unfortunately for us, it's never the same standard, which kind of defeats the purpose of standards. So that's the data itself. In terms of getting the data into our platform, that's the second challenge that we have. And the main challenge there is just the sheer number of systems that we need to integrate with, not only the systems themselves, but also the permutations of the various versions of those systems. So ideally, those systems have clean REST APIs we can interact with. Many times they unfortunately don't, which means that we need to do more direct integrations for things like brokers, like MQTT brokers, for example, or directly against databases themselves. Ideally there, they have things like change data capture systems that we can work with, but in the worst case, looks like scheduled, batch-oriented direct JDBC calls, which is not a fun place to be. We also have a set of push-based integrations, and these are a little bit better for us. You don't have to deal with some of the networking issues that you have to deal with pull-based systems, so you don't have to worry about things like VPN tunnels or firewall rules getting in the way. Ideally, we get information directly off of those sensors on the assets themselves. But in many cases, we get file uploads or drops of CSV files, zip files, and they may come to us in daily, weekly, monthly roll-ups, where again, we're still stuck with either ELT or ETL batch processes on our side that we need to maintain. So still fairly complex. Once the data is in our system, data volume and velocity is sort of the next fun problem that we encounter. So if you look at the slide here and imagine that each row is a sensor emitting readings, and let's say that each sensor produces 150,000 readings a second, that by itself is not all that challenging, but in reality it's not really 3 sensors, it's more in the order of thousands. And if you multiply that by tens or thousands of assets that you're monitoring, times hundreds or thousands of tenants, each with multiple different data integration paths and associated data flows, we found that compounds pretty quickly. And it looks great on PowerPoint, but in reality it actually looks more like this in practice. So data often comes in out of order. It might be bursty. So for that, think of an example of, say, a mining truck. It goes down into a mine all day. It's buffering that telematic data for a number of hours, then comes back out of the mine, reconnects back to the network, and then you get a sort of a burst or an upload of all of those readings for the day. Data may come to us incomplete or worse, invalid. So think there of sort of a poison pill scenario. So you might have a value that you receive and it's a double today and it's a double tomorrow. And then every couple days it comes in as a string or some other unexpected type. So your system that you build needs to be resilient to those sort of anomalous behaviors. And then in addition to that, data might come in duplicated depending on your message guarantees of your underlying platform due to transient issues with the network connectivity, for example, or it just might be missing completely. And there are various mitigating steps you can take to work around all of these issues, but something we found, like anything in computer science, that really comes down to the set of trade-offs you're willing to make within your platform. So if I step back up here for a minute, I've talked through data ingestion there on the left-hand side of our end-to-end flow. Other capabilities that we require toward the bottom there, we need a set of batch capabilities. So these are things like data exploration, so that our data scientists can make sense of the data that's come in addition to things like training of the models themselves. And then just generic batch platform capabilities like scheduling, resource management, things like quotas, throttling, things of that nature, and audit history of runs. At the top there, we also have a set of streaming capabilities that we require. This is for being able to apply things like validation, transformations, or normalization of the data as it comes in. Streaming rules for things like outlier detection, and then scoring of the models themselves. And then, as I mentioned, the ultimate goal of the platform is to generate insights back to our end users. So in the upper right here, we also have a set of application building capabilities to be able to quickly configure apps to be able to surface those insights back to our end users. And then I also have some additional capabilities called out here that I'll come back to more in a moment. So we decided to build this system, and then everybody celebrated and high-fived. We did it. And then as our second and our third and our fourth use case came along, we just applied that same pattern sort of in cookie-cutter fashion over and over and over. And leveraging the horsepower of AWS behind us, it actually made that process pretty straightforward and pretty easy. But one thing we found is over time, the more you do that, the consequence of that is that it becomes harder and harder to maintain that consistency across all of those individual instances. And inevitably, at some point, variance starts to creep into your system. So for us, at some point, we stepped back and we changed our mindset and our approach a little bit and moved away from that pattern of just repeating the same thing over and over to more of a platform mindset where we focused less on solving the immediate need and more in terms of reusable capabilities. And one thing you'll find is that's actually not that uncommon of a path for startups to take. So you partner with your first client, you build out exactly what they need, you're delivering business value, and you can actually get pretty far doing that over and over, but at some scale, it becomes cost prohibitive to keep doing that. So you start to evolve, where for us, that looked like a few things. You start to move away from sort of one-off snowflake or bespoke implementations and more towards reusable or generic self-service capabilities. From an organizational or process standpoint, you start to think of things less in terms of stories and team backlogs and more in terms of self-service capabilities. So the key point here is you really want to enable your users to leverage the platform to do the job they need to do without requiring them to interface with an engineering team that then takes 2 or 3 sprints to actually make that real. And if you begin to do this, you start to achieve some economy of scale, as well as you start to drive down your total cost of ownership, not just from a hosting perspective, but also from an organizational overhead perspective as well. And as you do this, everyone's use cases will be a little bit different, but for us, that fell into a number of buckets here. As I mentioned, on the data ingestion side, we started to identify our most common data sources, data integration patterns, pull those into reusable connectors, and then built out a set of repeatable capabilities to enable us to easily configure and deploy and monitor those connectors over time without the end user having to deal with that each time. We also built out what we call data catalog and management capabilities. These are things like being able to define new objects within your system, being able to evolve schemas over time, and then having the backing automation in place to be able to automatically apply those configuration changes to the underlying data stores and data flows to power the platform. On the stream processing side, the main goal for us here was to be able to enable data scientists to create new data flows, generate new data sets, without having to require them to interface with engineering teams each time, and not have to be experts in all the stream processing fundamentals that are required to make this real, things like watermarking, checkpointing, partitioning of data. They no longer have to know all of that just to get their job accomplished. On the batch processing side, our main goal for this was to provide a clean, standardized data access pattern for our data scientists. So regardless of where the data came from, what data format it may have come into the system in, they have a repeatable pattern for querying that data, and then layering in things like application of authorization policies on top of that. So again, it's one less thing for them to worry about. And then lastly, for a platform to be real, you need some level of operational tooling in place. So for us, this is instrumentation of all of our services, all of our data flows, our connectors, and our backing infrastructure to give you the observability into your system so that you're able to face some of the challenges and scalability concerns that we mentioned. So we built all of this with the ultimate goal of providing a platform for our data scientists to have a seamless way of onboarding data within the system in a simple, efficient, and repeatable pattern. And we did this for a couple reasons that I'll give it over to Dan to talk through as part of our Facts of Life.
So thanks, CJ, for running through kind of the problems we solve in our evolution as a company. There's one other piece that I want to kind of dive into, and it's facts of life when it comes to machine learning. So in 2014, several researchers at Google published a paper, and they basically say machine learning is the high-interest credit card of technical debt. And this is not because the machine learning code is hard to learn or it's difficult to kind of reason about. It's mostly because of all the supporting services and everything that you need to get up and running and also have repeatable. So like CJ was mentioning, data ingestion flows, data validation, remediation, those things have to be consistent in training as well as in your runtime for scoring. So to kind of call this out with a graphic, it kind of looks like this. The green box in the middle, we have what people talk about. So this is what everybody says, AI, industrial AI. But really, the hard parts from a data engineering perspective are all the blue boxes that we have around here. So only a small fraction of the real world ML systems are really focused on solving the green box. They have to take care of all this other stuff around it. And everything is hard. So these are difficult problems to solve as you go because in data science, changing anything changes everything. And this is an axiom that I've learned upon starting at Uptake. You have to have things that are repeatable, but not just repeatable. You have to have the same validation in place for training. Otherwise, the models are out there, they're running, they're scoring things, and you may not detect that there's actually like false positives, or it's not detecting something because your remediation process changed, or data validation changed, or the way the data arrived and how it's clustered changed. So that training context doesn't know. So you have to keep this in mind. So as you build the data verification, ingestion, et cetera, and the tools to monitor that, you have to be aware of all of those things impacting data science that does scoring, because ultimately, the only thing you care about is getting your insights out and actual outcomes from that. So just to recap this small extra flavoring, I kind of put an XKCD up here. You know, it's a pile of linear algebra, and we just mix it until we get the right output. But really, we take this data that's super dirty from the source systems, and we scale it up to 150,000 writes per sensor, with an asset having thousands of sensors, hundreds of thousands of sensors, or us aggregating those across a tenant. And then you spin up data science models on top of it after you do training. So what could go wrong, right, in this whole process? So as a startup, we've done this process over time, and CJ kind of shared our evolution of platform a little bit. But I'm going to talk about continuous evolution because I think it's so key to growing. So there's 4 points that I really want to dive into here. Really, it's number one is proof of concepting. Number two is building things out. Number three is learning from those things and kind of reincorporating them. And 4 is automating and making that process as repeatable as possible. So for proof of concepting, this is really like getting from works on my machine to actually working in the cloud. And this is where like AWS really allows you to go all in as soon as you're ready to start. So you want to create real world data science models and real world data sets. And in order to do that, you need to take some subset of that and get it quickly spun up so you can experiment and play around. This is where AWS will let you spin up any type of resource super quickly, or you can use like the managed services like SageMaker. You could choose to do the beefiest boxes or lean into GPU-based programming, but AWS has all of these things ready for you to do a proof of concept. And the goal here is really take your idea and prove it out. Just make sure that it actually works the way that you expect, or that you can say that it's valid. Once you have that all set up, this is really where you go next. So this is scaling out. When you think about this, in proof of concept phase, everything's on the table. You don't really have to make many trade-offs. This is where you're saying, I have a specific use case for data ingestion, and I need to account for real-world data sets on distributed systems. So all the complexity that you kind of like ignore in the first part comes in here. And this is where like managed services or elastic scaling can drastically reduce the time to go from like that proof of concept into actual production code. It's very easy if you are choosing good abstractions, which AWS managed services have a ton of, to kind of lean in and scale up and out without having to do much work on your end. So really like using the infrastructure as a service, and you might start with something that's not custom at all. It's just like out of the box Postgres running on RDS. And then as you grow, you might find you have to tweak that, or you're doing sharding or something else custom. You can layer that on top or look at other offerings they have. So if I come back here to the hard parts, AWS checks the box across the board, whether it's data collection, process management, monitoring, orchestration across the serving infrastructure. All of those things are there. Even some of the more like things that are based around ML or out-of-the-box ML are now coming online. So you can see that if you're using the AWS stuff, you can quickly get up to speed and kind of out to production. So the last, or the third step here is repeatability. So you do all this stuff, you get things up and running, but before you can go do more proof of concepts and start running, you want to kind of take the patterns and distill out of the work that you did what the trade-offs and what architectural decisions you made were. At this point, you kind of go from saying, instead of this bespoke kind of integration, I want to say, okay, here's the infrastructure as code bit that got this up and running. Here's how I think about scalability. Is it like up or out? Here's how I'm looking at compute, I/O, parallelism, offline processing. But in doing that, you kind of distill these things out as standards, and then the next time around, you have that context and you can learn from it. So because there are such a huge array of services, there's learning baked in at the infrastructure level already with many of the AWS offerings. And this is just kind of a call out to, when you're iterating, definitely pull those things out from an architectural perspective so you can continue to do that yourself. So the last thing I kind of want to throw out here is Layman's law of software evolution. And I think this is as true as when it was originally written. And it kind of says a program that is used and that as an implementation of its specification reflects some other reality undergoes continual change, or it becomes progressively less useful. Seems pretty obvious, but the point here is change is going to be constant as you're building things. And the things that you roll out initially from like a proof of concept should always be kind of, as you go to production with those, you're thinking about how can I continue to look at new contexts, new services that are offered, maybe you're entering a new type of integration or a new type of technology. And you come back to this question of, do I continue to invest in what I have, or am I going to kind of build it again? Because otherwise, if I don't do anything, I'm going to have that system atrophy and end up building it again, even if I don't want to. So from here, we're going to kind of get into summarization. I'm going to hand it over to Brad Bovin. He's going to talk to you about data engineering the startup way and platforming. So thank you.
Awesome. Can you guys hear me okay? I have a different mic than they do, so I'll try to speak up. So thank you very much to Dan and CJ. As I stood off to the side awkwardly, they were talking to you about a lot of the things that I'm going to kind of use that context in order to stand on my soapbox a little bit and talk about the principles that have got us to where we are from a startup, both from a data engineering perspective and talking a lot about platforms and how we think about them. I'll definitely say that we've evolved to get to this mindset. You don't necessarily start with this, but I think the principles and the tenets that I'm going to talk about hopefully will help you inform the way that you'll go about it going forward. So, how did we start? We're talking about platforms, we're talking about data engineering. How did we actually start our platform? It wasn't like it is today. We'll talk at the end more about what our platform looks like today. But at first, it was a monolith. It was a group of prototypes kind of smashed together. It was tested locally, deployed on-prem, and then scaled out through AWS. From there, we kept building and iterating and proving that Uptake could predict the future. We use our data science and our platform and our engineering to be able to predict when assets are going to fail. So with our technology and with our data science built in, we're predicting asset failures before they happen, which allows our customers to be more productive, more reliable, more safe, and more secure. So from there, as we started to scale and grow, we moved more into a microservices architecture, which allowed us to decouple our teams and really increase the speed of our experimentation, allow teams to have better ownership over their services and control their operations and own their code better than they were before. So this allows you to create those independent life cycles that happen kind of team by team. As part of this journey, AWS really allows you to be flexible and use as much of it as you want at different times. Going from being able to take fully managed services, which we'll talk about quite a bit, all the way to we have bare bones EC2 instances, which you can customize and do whatever you want with. So as we go through this journey, and both Dan and CJ talked about this quite a bit, iteration is key here. You're trying to survive, you're trying to figure out what's the next thing that's going to land you the next big client, what's the next feature that you need to get out. Just iterate, and evolve, and figure out the decisions that you have to make in order to get there. All right, so data engineering the startup way. There's about 5 different things that I'm going to focus on and talk about, and so we'll go into each one of these in a little bit more detail. So first, focusing on value. Leverage AWS. Focus on the things that matter to you and your business. Simplify the problem set that you have. Don't solve problems that you don't have. Don't create problems for yourself that you don't have. Know what it is you're building and focus on those things and those things only. You can create problems and focus on edge cases and all that type of stuff. Focus in on what's really important and offload the rest of it to services like AWS that can allow you to leverage those managed services to go further faster. Make trade-offs. Force them. Know what those trade-offs are, understand why you're making them, but make them. They're really good for what you're trying to do early on. Next, focus in on a specific problem set. There's, building a platform that's generic and can do a lot of things. You don't start there. You start with laser focus on what it is that you want to build and why you want to build it, and having everybody on your team know why that's important. So make sure that that's fundamental in the way that you approach this. Finally, focus on, again, what's critical path. In doing so, buy, partner, leverage things like AWS, leverage open source. Figure out the things that can make you go faster without you having to spend the time to maintain and build and ultimately own those services out in production. Figure out the ways that you can offload that responsibility to someone like AWS. Next, choose good abstractions. So abstractions over different managed services like AWS allow you to iterate and scale and simplify your deployment cycles. So that's going to give you more flexibility because things are just going to change. Things should always be changing and you need to embrace the change because it's going to keep happening. Ultimately, the code that you're running right now, you should aspire to not running that code 12 months from now in production or maybe even sooner than that. So embrace the change. Understand that's going to keep happening and create abstractions over that to minimize the impact that you have upstream in your stack. All right, act like an enterprise. This one is super, super simple. So when you use world-class global services, you get the service levels of world-class global services. So use them. They can be the backbone for the security and stability that you need as a business to turn a 2-person team or a small team into an army of people that feels like you've handled a lot of the hard problems that you could spend time and money on people developing and building for things that you don't need to. Leverage the enterprise class capabilities that you get with something like Amazon. That allows you to create and move very quickly and scale your business very fast. Next, invest. Invest in technology and invest in people. So from the perspective of technology, lean into platform and lean into platform early. It's really important to have that mindset early on. It's going to change, and the platform that you have today isn't going to be the platform that you have years from now, but having that mindset going in is going to change and alter the decision-making process that you have, and you're going to be better off for it. From a people perspective, invest in your teams, invest in your people, invest in your culture. We're going to talk more a little bit about culture at Uptake and how we do it in just a few minutes, but that's super, super important to building teams that are highly productive. When it comes to platform and leaning in there, think about things like what are the important paved roads? Things like AWS's best practices, Netflix paved road philosophy, they're real and they work and they're awesome. So read about them, understand what are the paved roads for your particular business, and make sure that you're on them and creating those paved roads for people on your team. All right, next, be open. There's a lot of incredibly smart and awesome people working in the open source community, solving projects that have a ton of value for things that you're doing right now. So leverage that open source software, contribute to it, and give back. Figure out how you do it. At Uptake, we both leverage a lot of open source in our stack, and we also have open source. You can find us on GitHub, Uptake Open Source. We've got a lot of awesome projects there, and we love to have any number of you as contributors. Then finally, have fun. Be flexible, adapt to the change that we talked about. Make decisions quickly so that your team can adapt to them. And just find ways to encourage a culture of having fun. I would say one of the most important ways to doing that is, leveraging cool technology is awesome, and engineers always want to play with the coolest and newest stuff. But actually doing stuff that matters and delivering code into production that's valuable for your users, that's delighting your users, and getting that feedback back to your engineers is going to be the best way to get them having fun and get them engaged in what they're doing. All right, so to take a step back, we've talked a lot about platform. CJ and Dan both kind of walked us through what is Uptake, how do we think about the world, and what are the problems that we're solving. We talked about AI and ML platforms in the IoT space. We talked about how it's just really hard problems that we're trying to solve to kind of make matters worse, so to speak. Dan talked about how when you make one change in an AI and ML platform, you ultimately are impacting everything in the system, which just compounds problems that you could have. And then I walked through some of the key tenets of data engineering in a startup sense that allow you to grow and scale your engineering team if you can kind of embody those principles and work with them. So now what I want to do is, we've talked a lot about platforms, what they are, why you should use them, why you should lean into them. And so hopefully most of you are like, okay, that's great, I get it, I want to do it, so how do I get myself one of those? So, Platform 101. What are the things that are really important when you're thinking about platform? And what are the important principles that you need to be thinking about? So, first of all, the most important thing that I would say is having this mindset and thinking about it definitely is going to alter your trajectory. So, number one, be opinionated. I really think that this is the most important aspect of what you can do. Make the tough calls. Figure out what you are. I think that especially early on, knowing the things that you're not actually end up being way more important than the things that you could be or that you're going to be in the future. Knowing that I'm not doing this allows you to avoid a lot of those specific edge cases where your engineers will kind of get wrapped up around, oh, well, we might have to solve this, or we might need to do that someday. If you're very clear about, no, we're not that, and we're not that right now, that allows you to simplify a lot of those decisions. Second is build a platform that allows your team to build software on top of it. So frameworks and toolkits that allow your team to scale out their systems and build them faster. That's going to be key when you think about platforms. So what are the ways that you can build tools that allow others to build other services and applications on top of those and not have to completely reinvent the wheel every single time? Furthermore, when you see them reinventing the wheel every time, ask the questions of, what is the opinionated call I can make about how this should work at my company? This is the way that we do it here, so that everybody's not trying to kind of reinvent the wheel in their own different team. By doing that, you can say, this is how we do it, and this is how we want to do it, and then allow, where it's absolutely necessary, some configuration parameters to allow you to kind of say, but it's a little bit different here, and it's a little bit different here, but this is actually how we really think it should be done. Next, we've talked about this quite a bit, but change is always going to be happening. You need to embrace it, you need to understand, you need to build good abstractions that insulate yourself from that change as you're building out your platform. Next, this one can be a little bit harder, especially early on, but separation between your platform and your applications is really going to be important. As you go, it can become very easy to let those things really commingle together, and that's going to force a lot of interesting trade-offs within your engineering team of like, okay, well, it'll be easier to have them become more commingled. Force the separation between them. It will pay off in the long run, and make sure that that continues to happen. All right, so you've leaned into platform, you've bought into some of these principles that we've been talking about. Now you need to start to scale your team. So you can go really fast early on with a small, close-knit group that's all standing around talking to each other all the time, and that's awesome. But eventually you're going to need to start to add to your team and grow the team. And I'd encourage you to not pay that coherence penalty of adding more people into the group for as long as you can. But inevitably you're going to need to. So when that happens, the most important thing is to create clearly defined service boundaries and contracts between those teams and communicate it out effectively to all those groups so that they know where those boundaries line up. There's always going to be complexity and uncertainty. So we talked about understanding and making clear opinionated trade-offs. That's great. The other thing that you really need to make sure that you're doing is identifying the things that will actually kill you. Those are the things that actually matter. Make sure you get data about what those things are and make the right decision. For all the other decisions, I would argue that making the fast decision that isn't necessarily right is actually going to be the better decision in the long run because it wasn't consensus-based and slow. Next, have a mission, be mission driven. Have your engineering team know and embody why what they're doing is important and how everything that they're doing contributes to that overall mission. Every person on your engineering team should be able to go and give your pitch about why what you're building is important. That's so important to driving engagement within your team. Finally, fiercely break down walls and silos around different teams both within your group and outside your group. So as your teams start to grow, it's going to become natural for, oh, this is my team and that's your team, even within the engineering group. Break down those walls and barriers and make sure people are really working together. And then outside of your engineering team, really make sure that there aren't any barriers and silos there. Everybody should understand and have visibility into what your team is doing and why they're doing it so that everybody's working together. So I talked a little bit about culture. Culture is ultimately going to be the lifeblood of what it is that you're building, because as you start to scale and grow, it's no longer just you as an engineering leader making the decisions. You have to push those decisions down. And so you need to empower people on your team to make the right decisions even when nobody is looking. So culture is driven by engagement, which ultimately drives execution. That's super important. So there's a lot of different ways that we drive culture at Uptake, and there's different inflection points as a startup grows. From 5 engineers, the culture that you have is very different from 20 engineers to 50 engineers and 100. And those different inflection points, you have to ask yourself, how can I continue to carry on the culture that I want, that embodies the way that I think about the things we need to be building? As part of that process, we do a number of things at Uptake, like hackathons and engineering talks and a lot of development opportunities within our teams where we have experts within our teams giving talks and talking about things that they understand really well and bringing in people to talk about things that we want to learn more about. All of that stuff is super, super important, but I would argue that while you definitely want to do that and there's definitely an amount of that thing that you need, the most important thing that's going to drive engagement with your teams is, like I said before, delivering software into production that your teams understand how they fit in, they understand the vision and why it's important, and you're getting that feedback loop back to them to say, my thing is important because it had an impact on my customer's bottom line, or it changed the way that they worked. Okay, so we've taken a journey of data engineering at a startup. We've talked a lot about platforms, scaling and building out your team. So let's talk a little bit about Uptake's portfolio of our platform, our applications, and the services that we offer. So at Uptake, I'll talk about the specific incarnation of the platform that we have today and the way that it looks like today, based on the way that it's been evolved from what CJ and Dan both talked about, kind of embodying the principles that I've been discussing. But one of the key things that we build on top of that platform is our applications. So our products are focused on KPIs and outcomes that deliver financial outcomes to clients within industry. Uptake's DNA is all about industry, and that's at the heart of everything that we do. So our applications are delivered software as a service that target specific KPIs within our customers' businesses that we're trying to affect and move in the right direction. Our services offerings are comprehensive in that we take both our platform and our products and applications built on top of that platform and customize them to meet you wherever you're at on your digital transformation journey. All right, so we've talked a lot about the platform. The Uptake platform today is something that we've built from the ground up. So we got a lot of insight from both CJ and Dan on exactly how we've done that. One of the things that I think is most important is this idea of an AI-first platform. A lot of the other people in this space, they have kind of bolted on AI over time, which is not something that we've done. We've thought about AI from the very beginning. As Dan was saying, a change in an AI and ML platform affects everything else in that system. So you have to think about it going in. And if you do it as an afterthought, that's going to create a lot of suboptimal results within the platform and the applications that you build on top of them. So our platform is fully managed, and what that means is that you don't have to take a bunch of disparate parts off the shelf. We connect out to your assets, both your IoT-enabled assets as well as your ERP and CRM systems, and pull all that data into one place. We use that in order to transform the data, to process the data, ultimately in service of getting it ready for data science. So from the data science perspective, we allow engineers and data scientists to build data science models, to deploy data science models, to train data science models, and then to operationally run them within our platform at scale, while also measuring and tracking results of those models and allowing our users to do that by bringing those results back into the platform, which is something that often goes unnoticed at companies that are doing data science, where they're ultimately creating models, but they're not actually benchmarking and understanding how well they work. So the last thing I'll say about our platform is really this democratization of data science. And what that means is that we've really enabled a platform that allows it to work across the spectrum of data science expertise and capability. So you have junior data scientists and data analysts that can come into the platform and with a few clicks deploy data science that's going to create meaningful financial outcomes for your business. But we also have expert level tools that allow data scientists that are coding and working with our SDKs and toolkits to deploy models that run alongside Uptake models within the platform and get all the benefits of versioning and scalability and operations and that performance management process that I was just talking about. So, wrapping up, like I said, I was on my soapbox a little bit here about the way that we've approached these problems and the principles that we think about and what that looks like. But hopefully you can take some of these principles that I've had here and apply them to your business. So, firstly, things I want you to take away from this. Uptake is awesome. I want you guys to come and talk to us more about it. Whether you are interested in our platform, our applications, curated data sets that we have. We're at booth 2714 over in the Venetian, so I'd love you guys to come over and talk to us more about what we're doing there. Second, there's really hard problems in this space, and Uptake is out here solving them, and this is the approach that we've taken in order to solve them. Leveraging some of the tenets that Dan and CJ talked about, as well as some of the principles that I've been going through. You have hard problems, and if you embody leaning into platform and thinking about data engineering in the right way, you can absolutely solve them too. last, AWS is there to make your lives easier. Embrace it, use it. It really, really does make your life easier. So especially for startups, leverage as much as you can, lean into those managed services, and make sure you're taking advantage of everything that they have to offer. Next, once you're up and running, build, learn, repeat that process, iterate and evolve. We've talked a lot about the different ways to do that and the life cycle that we've had to go through at Uptake. You're going to have your own journey and it's not going to look like ours, but make sure you're building and iterating and learning from the different things that you're putting out there. Then finally, make sure that you and your teams are having fun. We talked a lot about culture and the ways to affect it, but that's really important to driving engineering culture forward. So, I guess one more time, we have curated data sets. We have a lot of use cases and case studies that we can talk about at our booth 2714 over in the Venetian. Please stop by and talk to us. But now Dan, CJ, and I are all here to answer questions if you guys have any.
I'm sure there are many questions. First of all, a round of applause. That was a great presentation. So for those, the way we're doing questions, the best, most effective way, if you go to slido.com and push in startup, you can put in a question. It appears here, and we'll take them off the stack this way. So first one, what was the hardest problem you solved at Uptake?
Yeah, so I guess we've been talking about this for quite a while. It's really just all the variance in the system. As Dan mentioned, any change anywhere can affect everything else downstream of the platform. So really it's been how do we control that? How do we control that at scale, not just for one tenant, but for all of our tenants? We've spent, I think, years trying to tackle that problem.
First of all, Philippe says solid talk. I think we can all agree. Can you tell us how your platform handles A/B testing and continuous model improvements?
Yep, I could probably take that one as well. So our data science engine that runs our model scoring allows us to deploy our models for scoring in pilot mode. So what we're able to do is deploy multiple versions of our model, and then we have something called our model performance report, which gives that data-driven feedback that Brad was mentioning back to the user to be able to deterministically say that yes, this version is producing better insights than this version.
And I have a quick question. What's a use case that came out of it that when you started, you didn't think this is going to be something that was possible, and you're kind of surprised at what you're able to accomplish with Uptake or what you're able to detect?
Sure, I can take that one. So as I was saying, we have a lot of use cases like this, but I'll talk about one of the use cases within rail. We have a class 1 railroad where we've been processing over 2 billion data points for them every single year that feeds into over 34 different deployed prediction models that is actually predicting failures for those locomotives. We've predicted over 554 failures for those locomotives, which translates over to $160,000 per locomotive per year, which is millions of dollars in savings for those. At the same time, it's allowed the technicians on site to have 2,000 days prior warning to when those failures are going to occur, which just allows them to kind of shop assets, which is a very expensive thing to do, at the right time in order to be able to solve problems before they happen out on the track.
And just to add on there, that's the startup way, proof of concept. We get a huge packet of data. What can we do with it? And don't limit yourself.
This next person is very protective over their identity. So naturally, their question is, how do you handle access control for the data?
So I can jump into that one.
Sure.
We take data entitlement very seriously, same for multi-tenant support. So when you're on the platform, you feel like the platform is all yours, and indeed your data is secured all the way down to the row level storage. We're able to look at auditing information. We also have a end-to-end authorization framework that sits in front of everything. So every microservice has access to that. So we get context about who you are, what your policies are, what data you have access to. And that flows through to even the backend services. So things that are running like model performance reporting or doing pipelining, they're all entitled, and the access control is all in place for those.
I think that's a common challenge. Data is dirty. So how do you handle that? Can you talk a little bit about how you clean that up, how you work with that?
Yep, so I can take that one. So that's a common challenge with any data integration. I've been dealing with this years before I even came to Uptake. And really, the sort of force multiplier that we found here is sort of moving away from every time we have a new data set or a new data source, not requiring an engineering team to spend weeks or months configuring some system, and we've tried out a number of different approaches there, and really transitioning to that self-service model where you don't necessarily need to know all of the engineering underpinnings of the platform. You just need to be able to work with the data in a simple mechanism to get it in. And then we have some drag and drop UIs that, at least for the simple use cases, make it very trivial to say, I want data from data source A, I want to filter out these things, transform them in these ways, and then pipe them to these data stores, and make that sort of end-to-end workflow down to the level of minutes where it used to take us weeks or even longer.
Next question, a lot of people wonder this. I mean, we have over close to 1,000 plus services, 130 plus. How do you how do you gauge what to use? How do you test stuff? How do you figure out what the right services are, even discovering them to solve the problems you're tackling? Can you talk about how you discover these and test these out?
So I can kind of jump in there. I guess the first thing that kind of comes back to is what problem are you solving and how are you kind of tackling that? So getting clear about that laser focus on what you're going to tackle, and then looking for all the supporting pieces for it and diving into what can AWS help me with there. I think the other thing, if you notice in Brad's slide where we talked about, we started off as a monolith and we moved to microservices, now we're platform. Understand that there's an evolution and it's totally okay to get your proof of concept up and running. So like build it right, and then build it fast. Don't try to do all those things at once. I'd also say any of the AWS architecture or solution experts, they can totally you just explain the problem and they'll jump in and point you in the right direction.
I think something I always try to encourage people to do is, you might know how to solve something 2 years ago, but there's always new stuff coming out. So before you start building something, just search, just Google. There's somebody who was doing machine learning 2 sessions ago, and they looked, and SageMaker just came out that day. And they're like, oh, this is perfect. I'm going to use this now. So there's always some newer, easier, faster way to do something. Just stay educated on it. Have you thought about deploying your software on-prem? Is it always on your systems? Can you talk about that? Is that a limitation for your customers?
So yes, we have thought about this quite a bit. We ultimately can kind of go across different clouds so we can meet you where you're at. There's definitely a significant population of enterprise clients that, especially within the industrial space, are having trouble in their early part of their digital transformation journey going from on-prem into the cloud in the first place. So helping them evangelize the value of doing that, both from a security perspective and a lot of other things, is one of the things that we have to do quite often. But we have actually deployed into customers' on-premise systems and integrated with them. So we've done that in the past, and that definitely creates, when we talk about platform and thinking about that, that definitely creates some compromises and some trade-offs that we have to make when we're thinking about doing that. So we only do that in places where it's really critical for us to do that, and frankly, the size of the deal that we have is really, really large. In general, we're being cloud agnostic so that we can work in AWS and we can work in other cloud providers so that we can meet you where you're at. And then there's a decent number of clients that just say, hey, look, we're just starting our digital transformation journey, so you can take our data and you can put it wherever you want. And so our kind of home base for where we go naturally is just to put it up in Amazon.
Fantastic. Super condensed amount of information. Really appreciate it. Yeah, you give them a round of applause for a great talk.
Thank you, guys.